Hello everyone, welcome back to our channel. Myself Reshma. Today we are going to discuss a very important topic from building materials, that is brick. This is our second class from building materials. Our first class is about cement. The main topics here we included are definition of bricks, constituents of a brick, size of bricks, characteristics of good brick, technical terms used in brick, bonds in brickwork. First one, definition and size of brick. The artificial material of construction in the form of clay is known as bricks. It is of uniform size and shape. Traditional bricks are of size 23 by 11.4 by 7.6 centimeter. And modular bricks has a standard size of 19 by 9 by 9 centimeter. Nominal size of brick is expressed with the thickness of mortar and it is about 20 by 10 by 10 centimeter. Finally, average weight of brick is about 3 to 3.5 kilogram. Next one, constituents in brick. Silica, alumina, lime, oxide of iron and magnesia are the major constituents in brick. First one, silica. Silica is about 50 to 60% and its function is to prevent brick from shrinkage, cracking and warping. Effect of excess silica causes brick to brittle and useless. That is, it destroys the cohesion between particles. That makes the brick becomes brittle. And next ingredient is alumina, and its composition of alumina in brick earth is 20 to 30%. Its function is it absorbs water and imparts plasticity to clay so that it can be properly molded. Alumina in excess causes raw bricks shrink and warp during drying. Next constituent is lime. Its percentage is about 5%. Its function is it binds the particles of bricks together. It allows sand to fuse or to melt during burning. That is, it acts as a catalyst during burning of the brick. Lime prevents shrinkage of bricks on drying. Excess of lime causes the bricks to melt and it loses its shape. Next component is oxides of iron. Its percent ranges from 5 to 6%. Its function is it imparts color to brick and it helps to fuse the lime and sand during burning. Ultimately, it provides hardness and strength to brick. Effect of excess oxide of iron is the brick becomes dark blue color or blackish in color, and also inadequate iron oxide results in an yellowish color. Next component and the final component is magnesia. Its percentage is about 1%. It decreases the shrinkage. It is responsible for reducing shrinkage. Magnesia causes yellowish tint to brick. Inadequate magnesia causes decay of brick. Next topic is characteristics of a good brick. Brick should have a sharp edges, and brick shall not break into pieces when dropped from a height of 1 meter. And the next one is brick shall have low thermal conductivity. And next point is brick shall be soundproof. Brick when broken shall show a homogeneous and uniform compact structure free from voids. And also, when soaked in water for 24 hours, brick shall not show deposits of a white salt when allowed to dry. And brick shall not have crushing strength less than 55 kg per centimeter square. These are the important characteristics of a good brick. Next one is technical terms used in brick. This is the figure showing the technical terms. The technical terms are stretcher course, bond, coins, bat, closer, also king closer, queen closer, beveled closer. First one, stretcher course. A course of brickwork showing only stretchers on the exposed face of the wall is known as stretcher course. And bond is the method of arranging bricks so that the individual units are tied together. Queens, the stones used for the corner of wall of structure is known as queens. And next one is bat. It is a portion of a brick cut across the width, not length, cut across the width. And next one is closer. It is the portion of a brick in such a manner that its one long face remains uncut. And this is the figure which shows half brick batch, queen closer, king closer, bevel closer. Next one is queen closer. It is the portion of brick obtained by cutting a brick lengthwise into two portions. Here we can see the figure of queen closer. From here we can see the brick is cut lengthwisely. And next one is king closer. It is the portion of a brick obtained by cutting off the triangular piece between the center of one end and center of one side. From the figure of king closer it is clear. Next, beveled closer. It is the portion of a brick in which the whole length of the brick is beveled for maintaining half width at one end and full width at other end. From the figure it is clear. Next, bonds in brickwork. Stretcher bond, header bond, English bond, Flemish bond, garden wall bond, zigzag bond are the main bonds in brick. First one, stretcher bond. In stretcher bond, bricks are laid as stretchers on the faces of walls. This pattern is used in only for those walls which have thickness of a half brick wall. It is used as partition walls, division walls, etc. The bond is not possible if the thickness of wall is more. It is only up to a thickness of half brick wall. This is the figure showing stretcher bond. And next one is header bond. Bricks are laid as headers on the faces of wall. In stretcher bond, stretchers on the faces of wall. That is the difference between stretcher bond and header bond. The pattern is used only when the thickness of the wall is equal to one brick. In stretcher bond, it is half brick wall thickness. In header bond, it becomes one brick wall thickness. This bond does not have strength to transmit pressure in the direction of the length of wall. It is used in construction of footing. Stretcher bond is used in partition wall, division wall, etc. And header bond is used in footing construction, construction of foundation. Next one is English bond. It is the type of bond in causes of headers and stretchers alternatively. This bond is considered to be the strongest bond. In this bond, vertical joints of the header course come over each other. Similarly, vertical joints of the stretcher course also comes over each other. Every alternate header comes centrally over the joint between two stretchers. There is no continuous vertical joints in English bond. It is necessary to place queen closer in the heading course for breaking the joints vertically. And this is the figure shows English bond. From here we can see here there is no vertical joints. And next one is Flemish bond. In this type of bond, each course is comprised of alternate headers and stretchers. Each course is comprised of alternate headers and stretchers. But in the case of English bond, alternate courses of headers and stretchers are placed. Coming to Flemish bond, in each course there is alternatively headers and stretchers are placed. This bond creates better appearance than English bond, but it is not much strong as English bond. Every alternate course starts with a headers at the corner. It is of two types, double Flemish bond and single Flemish bond. This is the figure shows how a Flemish bond looks like. And comparison of English and Flemish bond. English bond is stronger than Flemish bond. Flemish bond gives more pleasing appearance than English bond. Broken rings can be used in the form of bats in Flemish bond. However, mortar required is more in Flemish bond. Construction with the Flemish bond requires greater skill. Skilled labours are required. Next one is garden wall bond. As the name suggests, this type of bond is used for the construction of garden walls, boundary walls, compound walls. It is used where the thickness of the wall is 1 brick thick, the height does not exceed 2 meters. This type of bond is not strong as English bond, but it is more attractive. This is the figure shows how a garden wall look like. Finally, zigzag bond. In this bond, bricks are laid in zigzag fashion. This type of bond is commonly used for making ornamental panels in the brick flooring. And here we are concluding. Thank you.